In this video, we're going to talk about advanced trinomial factoring, such that when we have ax squared plus bx plus c, a is not 1. Last time we were talking about when a was 1, but this time a is not going to be 1. Now, last time we talked about finding the factors of c, and they had to add to b. Well, because a is not 1, we can't do that, or we can't do that immediately. We have to take this a into account. We have to do something with it. So what we're going to do is we're going to take it and we're going to slide it over and multiply. Alright, so we're going to do 2 times 3. We'll have x squared plus 7x plus 6. Well, now it is identical to what we were doing before. So we're looking for factors of 6 that add to 7. Well, that would be 1 times 6. 1 plus 6 is 7. 1 times 6 is 6. So we put that into our form. So x plus 1, x plus 6. But this time, instead of just stopping there like we did last time, well, we had to take care of that a to make it work for us. But that changed the base trinomial. So we have to take it out again. So once we have found the factors that work, we're going to divide it out again. So divide by the 2 that we multiplied by before. Alright, and now we're going to simplify the resulting fractions. So 1/2, well, that's as simple as it's going to get, but 6 over 2, that's 3. And the last thing we're going to do is we need to rewrite it without the fractions. So how that works, we're going to take the denominator, whatever that is, and we're going to move it to right in front of the x. So our final answer here would be 2x plus 1, x plus 3. Okay? So this is called the slide and divide method of factoring. The slide and divide method, which is basically, it's a variation of the product sum method that we talked about before. Okay, so let's do another one. We'll call that one example 1, and let's look at here. Okay, so the first thing on our mind should be that a is not 1. Okay, well, the second thing we want to look for is there a GCF? Well, no, there isn't. 3 is prime and it doesn't go into 8 or 10, so there went that idea. So once we have determined that both of those are accurate, we're going to slide and divide. Alright, so we're going to start with the slide part. So we take the a, the 8, and we multiply it to our c, so 8 times negative 3. So we get m squared minus 10m minus 24. And now we're right back to where we were in our previous section. So we find the factors of negative 24 that add to negative 10. Okay, and it's factors of negative 24, so they need to multiply to get a negative. So one of the factors has to be a negative and the other factor has to be a positive. So 24, so we got negative 1 times 24, well that adds to 23. Positive 1 times negative 24, that adds to negative 23, and we want a negative 10. So our larger factor needs to be a negative to be able to add to a negative. 1 and 24 don't work. How about 2 and 12? Well, 2 times negative 12 is negative 24. 2 minus 12 is negative 10. So there we go. So we put that into our form. So plus 2 minus 12. And now that we found the factor pair we need, we are going to divide by the number that we multiplied by before. So we're dividing by that 8. Now we simplify the fractions. Okay. So 2/8, that would become 1/4. And 12 over 8, that would be negative 3/2. Okay, and you can always confirm with your calculator. If you have a TI-83 or a TI-84 calculator, you would hit Math, and then you would find the little thing that says, it's a weird sideways triangle, and it says frac. That's into fraction. So that takes it from a decimal to a fraction. So you can confirm your calculator that way. And the last thing we need to do is rewrite without fractions. Okay, so our final answer for this one would be 4m plus 1, 2m minus 3. Because whatever that denominator is will get put in front of the variable. Okay, so let's do it again. We have 3x squared minus 15x plus 16. So a is not 1. Is a GCF? Well, 3 does go into 15, but it doesn't go into 16, so there's no GCF. So what we're going to do is slide our a over. So 3 slides over to 16 and multiplies. So we get x squared minus 15x plus 48. Okay, so we're looking for factors of 48 that adds to negative 15. I'll start at the top of the list. So if it's positive 48 and a negative 15, then both of the factors have to be negative. A negative times a negative is a positive, and a negative plus a negative is a negative. So negative 1 times negative 48, well, that adds to negative 49. That's way too big. So what about negative 2 times negative 24? Well, that's negative 26. Still too big. Does 3 go into 48? Yeah, that's negative 3 times negative 16. Well, that's a bit better. That's negative 19. At least we're in the teens this time. So what about 4 times negative 12? That's negative 16. Ooh, much better. So close. 5 doesn't go into 48, but 6 does. So we get negative 6 times negative 8. Uh-oh. That adds to negative 14. Is our math wrong? No, our math is fine. Did we forget a factor pair? No, our factor pairs are fine. So this would be not factorable. otherwise known as prime. Every now and then you'll get a prime factor trinomial. In such a case, you would either say that it's prime, or the factored version of it would be the 3x squared minus 15x plus 16. There's nothing we can do with it. So how it started is as good as it's going to get. Let's have another. So we have 48y squared minus 86y plus 10. So a is not 1. Is it a GCF? Well, definitely 48 does not go into 10. But take a second look. 48, 86, and 10. There's a GCF here. They're all even numbers. So we have a GCF of 2 that we can pull out. So let's do that. So what do we get for our leftovers? We have 48 divided by 2 is 24, y squared, minus 86 divided by 2, which is 43y, plus 5. Okay. So, just looking at the inside of the parentheses, let's do it again. A is still not 1. Is there another GCF hiding? Nope. 5 is prime, and 43 and 24 don't go into it either. So, no GCF. So now we can do the slide and divide. And we're just focusing on what's in the parentheses. So the 24 slides over to the 5. So 24 times 5. So we get y squared minus 43y plus 120 for that. Okay, so factors of 120 that add to negative 43. Oh, this might take a while. 120 is a big number. So let's start at the top and work our way down. So two numbers, the factors multiply to a positive 120 and add to a negative 43. So both factors have to be negative. So negative 1 times negative 120. Well, that adds to negative 121. Way too big. So negative 2 times negative 60. That's still too big. Negative 3 times negative 40. Ooh, there we go. That adds to negative 43. Yay! So put that into our form. Minus 3 minus 40. And now we're going to divide. And we're dividing by the number that we slid before. So we're dividing by that 24. Okay. Simplify the fractions. So we get y minus 1/8, y minus 5/3, and last we want to rewrite without the fractions. So our final answer would be 8y minus 1, 3y minus 5, and bring down that 2. This, all of it, this is our final answer. This is our factored form, including the 2 that we pulled out as a GCF to begin with. We have to include it as well in the factored form. Let's have one more example. We have 12a squared minus 5ab minus 2b squared. So we have two variables here. Does that change the math? No, not really. So the first thing on our mind should be, is a 1? And it's obviously not. Do we have a GCF? Well, 12 and 2 are both even, but 5 isn't, so we don't have a GCF. So we're going to slide that 12 over and multiply. So we get a squared minus 5ab minus 24 b squared. Okay, and now factors of negative 24 that add to negative 5. I'm thinking 3 and 8. So negative 3 times positive 8 multiplied to negative 24, and they add, oh no, that's positive 5. Let's flip it. 3 times negative 8, 3 minus 8, yes, that's negative 5. Okay, so put that into our form. So we got a, and we have plus 3 minus 8, and we're dividing out again by the number that we multiplied by before, so the 12. And we also have to have the b taken into account. If we have the a's in front because a is in front, then guess what? We have b's in the back because b's are in the back. Okay? The rest is identical. So simplify the fractions. So 3/12 becomes 1/4 b, a, 8/12 becomes negative 2/3 b, and rewrite without the fractions, so the denominator comes in front. So we would have 4a plus 1b and 3a minus 2b, except what do we have when we have a coefficient of 1? The 1 disappears. So for our final answer, we would have 4a plus b, the 1 being invisible, and 3a minus 2b.